Okay, hello everybody. Thank you for joining. This is a highly technical talk about Kubernetes and Hadoop, or most precisely about containerization and distributed application. My name is Márton Elek, and I'm an Apache committer in the Ratis project, which is an Apache incubator project. And this is a Raft library implementation. It's an embeddable Raft library, which is embedded, for example, in one of the new Hadoop subproject, Apache Hadoop Ozone. I also have a playground sandbox project on the GitHub, where I'm trying to containerize the whole world, starting with the Apache Big Data projects, such as Hadoop, Hive, HBase. And I have multiple solutions to run them in Docker Compose, Docker Swarm, Kubernetes, Nomad. And I'm working for the Hortonworks, and a significant time of my daily job is just starting new Hadoop cluster, stopping new Hadoop cluster, starting new Hadoop cluster. I really like it. I think it's a very good job, or depends from the toolset what you use. And I think the containerization is the right toolset to do this, because it's very powerful. And with containerization, managing Hadoop cluster, it's more easy, and the clusters are more manageable. I use Hadoop in this talk as an example. To be honest, it could be almost any other animal as well. But I don't know if you know the feeling that everything works well in a getting started guy, but with a real world application, it's not so easy, or it not works very well. So Hadoop, I think it's a good example. It's a very stable, old, mature application, and if we can containerize Hadoop, then we can containerize almost anything else. Okay, let's go forward. Do you know what's this? Anybody here from Europe? Oh, okay. I think it's known in Europe because it's a European regulation that every household appliances in the retail shops should be tagged a label similar to this one, just to make it easier to compare them, not just based on the price, but based on, for example, the I don't know, power consumption or noise level. And I think it's a pretty good thing. So it's much more easier to compare them. And what I would like to do is the same, but in the US. But to be honest, I'm not so interested about the freezers and washing machines. So I would like to do similar thing, but for the containerized environment. And what I'm interested about that, how can we compare different containerized solutions, that what are the key questions which should be answered somehow, independently if it's solved by a Docker Swarm cluster, or a Kubernetes cluster, or a Nomad cluster. So this talk is about these questions, that what we need to solve. But to check the questions, we need real-world examples, right? So we will check multiple examples to run Hadoop in a containerized environment. But unfortunately, we have not enough time to check all of the technical details. So what we will do is just check one good thing and one bad thing about every solution. To be honest, I'm most interested about the bad thing, right? It's more interesting to see the limitation of a specific solution. Okay, let's start with the container. Do you know what's this? Did you write something similar? Okay, okay. So this is the Docker container definition. So, but I think it's quite simple. So we have just we have a base image, we put the Hadoop, and that's all. That's the containerization. My original title of this presentation was How to Containerize Hadoop, but I just realized that it's just one slide, right? That's the way. This is the source, so nothing else. Done. Yeah, that's not the hard part. What is the hard part? Yeah, the hard part to answer the questions that how can we run the containers all together? How can we solve the configuration? So where the configuration will come from? Or what about provisioning? I need to start containers on different nodes. I need to define somehow the cluster, that I need name node, data node, Hadoop components. Maybe I would like to scale it up and scale it down. I may require multi-tenancy to start multiple Hadoop clusters on the same physical nodes. And also the network is also an interesting question, that how can I configure to connect data node to the name node. Okay, so let's start with the easiest part, the configuration. So this is a typical Hadoop configuration. This is a good old XML. I have no problem with the XML. I can do the same typos in XML and the YAML files, but this is the Hadoop configuration. The only problem is that from Docker side, the typical configuration which is used is the environment variables. So this is a Docker Compose definition. This is a definition for running one container. We have some image, so I would like to run some name node. I have a host name, some port which will be used, and configuration values, which are environment variables. Yeah, but Hadoop requires XML, but it could be solved easily, I think. It's just a few lines of code, and we can transform, because the real value is the configuration key and value set, and not the format of the configuration. So what we typically do, we use just environment variables based on some naming convention, and you can imagine that the core side.xml, this is a Hadoop configuration, it will be converted to a real XML based on the extension. We can define that, okay, the XML is a Hadoop XML format, and all of the key values are here. Okay, so that's a typical problem which will be solved. We didn't solve all of the problems. This is just one part, the configuration. But yeah, maybe we need some kind of pre-processing to enable or disable one feature, such like the security or Kerberos principles, just in one step, or maybe we need some more dynamic environment to restart the services in case of configuration change. Okay, but that's just one question. One other typical question about the containerization, that there are two main approaches to containerize big data application. One is just use the container as a node and put all of the application in that one node. And the other one is create separated container for every component. Okay, so what's the best? Yeah, it depends from the use case. But typically, or at least one part of the solutions use the approach from the left side. So the containers are used just as a nodes, and everything, every components are in the nodes. Because it seems to be easier first. For example, the existing management tools could support it very well. But I think the right side, it's also very powerful, and after a while it could be even more easier to handle. Because if the containerization is the unit of the packaging, then we can handle all of the applications in the same way. We don't need to manage it one by one in the same container and just create some restart logic. For example, what about if you would like to restart or upgrade the Hive in the left approach? You need to recreate a container, or you need some magic script which could restart and upgrade inside the container. With the right approach, it's very easy. I can upgrade just one container without stopping the other one. So if the container is the unit of the packaging, also, the real power behind the container is the script which could start the application inside the container. So typically, we don't start the real application directly, for example, the Hadoop name node or Hadoop data node, but we could have some helper script, the launcher, which could start. And yeah, because the Docker magic, the launcher script will be called with the real application which should be started. And that's very powerful, because we can do a lot of things to make it easier to run the distributed applications, such like as Hadoop, in the containerized world. These are just some very simple examples. For example, we can wait, because maybe we need to handle the dependencies between applications, or we need to format the name node at first time. And you can see that at the end, we are just starting the real application after this magic modification. Okay, so a few examples what could be added the script. So, for example, this configuration transformation, the magic from the first slides, we can handle the dependencies. So sometimes we need the master node before the worker node, but it's again just 4 lines of bash code. Okay, we can download additional components, ranger policies. We can prepare the HDFS or any components. We can format name node. We can retrieve dynamically the Kerberos principles. We can enable any kind of Prometheus monitoring with Java agents. So it's enough to modify a few Hadoop environment variables, and you can activate monitoring, for example, or activate more powerful developer tools. This is my favorite one. So we have a tool which could print out all of the network traffic in a parsed format to the standard output. So I can see, like an X-ray machine, that what's happening in the cluster and in the network messages between name node and data node. Okay, so it's very powerful, and we use it all the time, usually, this Docker Compose-based approach. We have a good launcher script, and we are just starting newer and newer clusters locally, such a pseudo cluster. For example, there is a new feature, this router-based federation, HDF, in the HDFS. It requires about 24 machines, but it's very easily could be started in this laptop. It just, I don't know, 60 seconds. So it's very powerful. We also use it for doing acceptance tests. What's the bad thing about this? Well, it's almost nothing, just one minor thing, that we can't do it in multiple nodes, right? This Docker is just about my laptop. I can start the whole pseudo cluster, but we need some more powerful thing to run the containers in multiple nodes. So what can we do? Yeah, the obvious answer is the Kubernetes, which is one of the most popular answer. That my problem with the Kubernetes here, that it's very easy to win a competition if there is no other competitor in your category, right? That's what Kubernetes can do it here. So I just created a competitor to make it easier to understand the key questions which will be solved by the Kubernetes. So this other approach is a do-it-yourself approach based on Hoshi Corp products. Do you use Consul or Vault or any other Hoshi? Okay, a few one. Okay, so Hoshi Corp is a company who produce a few more simple but very powerful tools, such like as Consul. Consul is a service discovery server, but you can imagine it as just a key value store. There are some additional features. For example, if the key is a service name and the value is an IP address, then it contains an embedded DNS server, so you can retrieve the information over the DNS interface. Vault is a secret management server, so again, it's just something like a key value store where the values are secrets or passwords. It also has some powerful functions such as dynamic secret generation or authorization authentication. And finally, the Nomad, which is a scheduler. Okay, that's what we need, but what is this? What is the scheduler? Well, the problem is that we have multiple nodes, right? So it's not one laptop anymore, but we would like to run Hadoop in multiple nodes. And scheduler, yeah, we have Nomad agents everywhere, so it's very easy because it's just one binary. It's written in Golang. And the scheduler could just start the container somewhere. So I'm not interested where it will be started. It's in a container, so it should be started somewhere. Or maybe I need 4 containers. I'm not interested where it will be scheduled. So that's what Nomad can do. And yeah, it also could start the good old Hadoop or HDFS cluster. We have worker nodes or data nodes, and we have one master node. Okay, what's the problem here? Yeah, the problem here that I don't know where the name node will be scheduled. So it will be started somewhere, but I need to configure the Hadoop to connect to the name node. Okay, what can I do? Yeah, there are multiple problems here. One is the network. So typically, if you install a Docker to a node, you will have a separated internal Docker network for your containers. Yeah, but if you have multiple nodes, it's very hard to connect from one container in one node to another container in another node. Different internal network IP addresses. You can do some magic port mapping, or you can use some external virtual network, but the easiest way to do is just don't use the Docker network. So it could be turned off very easily. So you can use host network, which means that still I need the Docker, because this is the unit of my packaging. So I need the Docker, but I don't need the network isolation. And it's very easy. So all of the containers will be started with the original IP, original host name, of the host IP and the host name. So it can just work as before. The only one limitation is that I can't start two name node, for example, in the same node, because I can't start two applications with the same port. But I don't think it's a big limitation, because I wouldn't like to start multiple name node in the same node, because the I/O will be limited anyway. Okay, so we solved this problem. So what's next? Yeah, that's, again, this the problem of choosing the right freezer. So we solved the network problem. We have host network. The DNS is working just as before. We could have data locality. Everything works well. Okay, but still we have a problem. So this is the configuration, and I need to configure the name node address. What is the host name of the name node? Yeah, I don't know. Who knows? Oh, it's not working anymore. Oh, HDMI is not working anymore. Can we do something? It's working here. The screen is frozen, so okay. Okay, let's start to do it in this way. Okay, so we were here. So the problem is that the name node will be started somewhere, right? I don't know where it will be started. Who knows? This is the scheduler. Yeah, if scheduler knows, maybe scheduler can save the information to Consul. Consul was our discovery server, which is something like the key value server, and Nomad can support it. Both of the products are written by Hoshi Corp, so there is very good support. So we can just save the information to the Nomad. And the tricky part is that Hadoop is not Consul compatible, that we need some magic script which reads the information from Consul, generates the configuration, and starts the data node. So from technical point of view, this is something like this. We have the Nomad, we have the Docker, we have the Hadoop instance inside the Docker. Nomad can start the Docker somewhere. I don't know where it will be started, but I can register the Nomad could save the information that where it will be started to the Consul, and we need this magic and powerful launcher script. The Consul template is an open source project, so it could be checked. And this starter script could render the configuration first, and after that, we can start the Hadoop Java process. Okay. If we have this not so simple solution, it also could be improved with additional features. For example, dynamic restart. So if something will be changed in the console, for example, name node will be scheduled to another node, we can just restart automatically all of the nodes. Or we can even upload the configurations without the dynamic part to Consul, and the Consul template just can download the configuration, render based on the dynamic information. So it seems to be very complex, right? So yeah, and the reason is that it is very complex. That was the do-it-yourself solution. But these are the questions which should be answered by a containerized environment, and these are the questions which could be answered, for example, with Kubernetes. Okay, just let me show an example. I don't know if is this, okay. Is it better? Yeah. So this is an example how does it look like. So we have some services here, and in the bottom of the screen you can see the console output of 2 data node. You can see here that the name node is scheduled to Nomad 2. This is a name of one of our hosts. You can see all of the configurations here. Yeah, I have HDFS configuration. Okay, this is a good old configuration, but you can see in the first line that there is a host. There is the magic to replace the host name of the name node based on the dynamic information. Okay, and I can go back and just modify the log4j properties, for example, the logging level, and yeah, I'm just modifying it and saving. And the bottom of the screen, you can see the console output, the log of 2 data nodes in some other nodes, and they are just magically restarted just because I modified the configuration in the console. Okay, I can close it now. Yeah. So I think it's definitely a very powerful tool. So it was the good thing is that we can do everything almost. So this dynamic restart is even more powerful than what we can do out of the box with Kubernetes. But the bad thing is right. It seems to be complex, right? There are a lot of small components. I just wired everything together with very tricky way. So what can do with the Kubernetes? If that was the out-of-the-box solution, do-it-yourself solution, Kubernetes is the out-of-the-box. It supports everything almost out of the box. Do you use Kubernetes? Okay. So just to be on the same side, from high level, Kubernetes is just another scheduler, right? The problem is that still we have multiple nodes, and I would like to start my containers somewhere. I don't know where it will be scheduled. Maybe I need an application with 2 containers or a third application with 3 containers, and they will be started by Kubernetes. But this is not just a scheduler. The big difference between Nomad and Kubernetes that Kubernetes can handle the containers together as an application. So it provides additional functionality. For example, network between the containers. We don't need this Docker host network magic anymore. All of the containers will see each other. Yeah, it's pluggable, and in fact, there are external network components, but it just works. Okay, we have storage. It's also pluggable, but we can mount the same volume, for example, NFS, iSCSI, to all of the containers. We can mount the same configuration. We don't need this Consul magic. We can just say, that is my configuration. Please mount it to everywhere when I would like to start the Hadoop. So it's very powerful. And to be honest, all of the complexity of Kubernetes, the resources, controllers, most of them are just definitions to run some of the containers. For example, we have daemon set, which means that I would like to start a container, a specific type of container on every node. Or maybe a replica set is just starting a container, doesn't matter where, but I need 5 instances. Okay, so it seems to be very good, right? It's very powerful. Maybe that's the final solution. It could be the better tool to start Hadoop. Well, that's one problem. The problem is that the way how Kubernetes think and Hadoop, it's a little bit different. So imagine that I have a backend application. I have 3 instances from the backend because Kubernetes can just scale it up. And I have a front-end application. The front-end application is a good old application, and it is written to connect to one backend. So what can we do? Kubernetes, out of the box, provides a component for that. This is the service. And this is something like a load balancer. So from the front-end point of view, it seems to be just one component. But in fact, there is a load balancer, and I could have multiple components. Yeah, it's very powerful. The only problem is that the service has a DNS address, but the pods have no DNS address at all. And what do we need for a good old stateful distributed application like Hadoop? We need DNS usually, because we have already solved the replication and the communication between the nodes to check all of this scaling problem. So that's a problem, not a big problem, but some differences between the approaches. Fortunately, we have the stateful set in Kubernetes, which is something like a container and a network address together. The only problem, there is no problem. Usually, this stateful set is used everywhere for Hadoop in Kubernetes. The one minor problem is that this is just one resource. For stateful set, I can't use, for example, this approach, the daemon set, without some very magic scheduling configuration. Okay, and in fact, I don't think it's a bad thing. It just and not a limitation. It's just some differences between Hadoop. But if we use the stateful set, we can start it in Kubernetes, and yeah, it could be very powerful. So let's check the good things about Kubernetes. Yeah, I have two favorite ones. There are multiple advantages of Kubernetes, but I have two favorite ones: the ecosystem and the flexibility. Okay, let's start with an example. I would like to monitor Hadoop with Prometheus. Do you know Prometheus? Okay, a few of. Okay, Prometheus is a monitoring tool, so it's under the cloud native foundation, similar to Kubernetes, and yeah, it just can collect all of the metrics from the components. And it's very easy, actually. We have a Prometheus server, and Prometheus server is just polling HTTP endpoints and collecting all of the metrics from the HTTP endpoints and just storing them. Okay. So we have two things, or we need two things here. First of all, we have no Prometheus HTTP metrics endpoint in our Hadoop. The other problem is that the Prometheus should know where are the endpoints. Okay, let's start with the first, the HTTP endpoint. So we need HTTP endpoint, and imagine that I wouldn't like to modify the Hadoop. Okay, until now, I said that, oh, I'm just starting container. But to be honest, I simplified a little bit the Kubernetes. We are not starting containers, but we are starting pods, which is a definition of one container together with the volume, network, and all of the requirement for the container. And in fact, it could be not just one container, but it could be multiple containers, which could share a lot of resources. For example, the network, the volume, or even the processes. And it's very, very powerful because, for example, I can add an additional container just to the same pod where the name node is running, which can just check the JMX interface and publish the Prometheus metrics over an HTTP endpoint. So I didn't modify the Hadoop or any. It could work. It could work with all of the Java application, with HBase, with Java. So without any modification, I just started to publish the metrics over an HTTP endpoint. So this is a Kubernetes resource definition. It's not very important to understand all of the details. In the bottom, you can see that there is some container definition, so I have image name or starting argument. The only important thing is the difference between the two slides. So to enable monitoring in a Java application, this is just 2 lines, or in fact 3, because I turned on the share process namespace feature. So 2 lines, I added 2 lines to the descriptor, and I have monitoring endpoint. And I think that's one of the power of the Kubernetes. Okay, still we have a problem, right? We have endpoints in the data node and name node side, but we don't know where the name node and data nodes are scheduled. In the Nomad version, we just checked it from the Consul. And yeah, it's very similar here. We have a Kubernetes API server, and we can check all of the available information and check where the name node and data nodes are started. And this is the ecosystem. So Kubernetes is not just one solution, but ecosystem. I think nowadays nobody can be successful with a new development tool without Git support, right? Because Git is so widely used that it should be supported. And I think sooner or later it will be, and I think sooner, it will be the same situation with Kubernetes. So I think most of the big products will support somehow Kubernetes. Prometheus already supports Kubernetes. Yeah, it's developed under the Cloud Native Foundation. So it could check the available endpoints very easily. Again, this is just an example of the resource definition, and the only interesting part is the difference. So I didn't do any hard thing, just added a few annotations that, oh, yeah, here in that container, you will have some information for you about the metrics. So, and yeah, this is because the Prometheus is created to support the Kubernetes. And yeah, I believe that sooner or later, it will be not just Prometheus, but other applications as well. Okay, so here, yeah. So that is the label of the Kubernetes. Most of the big advantages advantage of Kubernetes that most of the questions are answered by the Kubernetes. For example, the configuration. There is a config map resource, which is just an option to upload the XML configuration, for example, and it will be mounted to all of the containers without any other effort. Pre-processing, we have this Helm, which is a package manager, and we can do conditional processing. There is no dynamic support out of the box when the containers could be restarted without just with changing the configuration, but it could be added. So this is just a default set. I can use Consul here as well. So there are multiple ways to use Kubernetes. This is just one way, but with every way, but yeah, independently, how do you use it? You can just evaluate it with this question. Okay, so provisioning, scheduling, it's also, yeah, the multi-host support is provided by this network plugin by the Kubernetes. There are multiple options, Wave, Calico, and the scheduling is handled by Kubernetes. So there are multiple options, anti-affinity rules. The cluster definition could be the cluster could be defined with Kubernetes resource YAML files, similar what we saw earlier, or Helm package manager. Okay, it could. The scaling is out of the box supported. I can say that, oh, I need more data node. Multi-tenancy is supported because there are namespaces. I can start multiple cluster in the same Kubernetes. Failover is handled. The pod will be started somewhere else. And the network, from network point of view, with the stateful set, we have DNS. We have reverse DNS, and we have a network identity for every pod. So it's very easy to configure because I don't need to think about where the name node is started because the name node has a host name node. So the only thing what I should do is just use the name node in the configuration. Okay, so that's the Kubernetes. The only remaining question is Hadoop cloud native or not? Yeah, it depends from the definition, but I believe that it's almost cloud native. Hadoop is designed to be run in a distributed way. So it's a distributed application. So I think it's very easy to run in separated containers. There are some problems, but not big problems or not architectural problems. But for example, this DNS and IP handling. So in the Kubernetes, it's possible that the DNS will be changed very frequently. For example, to support this, there is an open Zookeeper issue. So it's just a small modification, and Zookeeper also could work better in Kubernetes. There are other few items which could be improved. For example, the configuration loading part of the Hadoop. But again, this is just a few steps forward or improvements, and from high level, it's very well supported even now. Or just an example, it's very typically that in a multi-tenant environment that name node UI or other UIs are accessed over a reverse proxy. So we need to support it over reverse proxy and not just as a root resource. But it could be added very easily, and I hope that it will be added. Okay, so summary: we shouldn't buy a freezer before we check the label. That's, I think, the big summary, and we can do the same for Kubernetes or every other containerized environment. I also believe that the containerization it's a very powerful way to manage the big data application, Hadoop, and other stateful distributed application, and it could be more easy to manage with containerization with the right toolset. And I also believe that Hadoop is a first-class citizen in this containerized world because it's designed to be distributed, and yeah, we should improve it to make it easier to run in containers. But even now, it's possible, and with some small tricks. Okay, that's all. You can check more source code if you are interested about technical details on the GitHub account, or do you have any question? If you have, please use this mic because it will be recorded. Okay. If not, I will be available, I think,
If you move to containerized infrastructure, what do you do about like configuration files and things like that that you would want to be persistent? Do you need to kind of pull them from source control in some kind of Ansible flow? Or is that a problem you've had to solve?
Yeah, so the question is that how can I versioning the configurations, right? Yeah, there are multiple options. For the do-it-yourself option, you saw that I can store it in Git and I can upload it. For Kubernetes, there is no easy or no out-of-the-box answer that how can you versioning all of the resources. All of the resource definitions are just YAML files. So one option is just you can commit all of them in Kubernetes. But there are other options to use higher level tools such as Helm chart. And by default, Helm chart is also just a definition, and the values are not stored in your local repository, but there are other options to save them in a Git configuration. I think in the Kubernetes, that area is not very mature, or I expect more and more tools to provide this kind of use cases or questions. Yeah.
Thank you.
Okay, so if no more question, thank you very much.